All right, area between curves today. All right, so if we are looking for, we've got a couple of functions, f and g. Two functions. As shown. So here's a couple of functions. So one of them, f can be this one. And g can be this one. If we want to know the area between them and between two x values, so a and b, so say for example we're after this area in here, then the area bounded by the two curves and the lines x equals a and x equals b, then, excuse me, so this area that we're wanting in here, so for us to get that area, what we do is we look at the area under f, and that goes all the way to the axis, but it's included this bit down here, which we don't want. We only want the bit up the top. So what we then need to do is we need to find out what this area is, the one under g, and we need to then take that away. All right, so integrals give us the area under the curve all the way to the axis. So if we're looking between two curves, and then you do the higher one all the way to the axis minus the lower one all the way to the axis. So it is area under f minus, take away, the area under g. And so in, excuse me, terms of integral from a to b of fx dx minus the area from a to b of gx dx. Or alternatively, if you want to put those together, you can put it together in one integral like so. Alright, so let's do some examples. So area, we've got a couple of curves, y equals x squared plus 1, y equals 4 minus x squared, and then we've got a couple of lines. So always with these, best idea is to do a sketch of some sort. It doesn't really matter how rough it is, but just so that we can get an idea of what's going on. Which one's the one on top, which one's the one not. So x squared plus 1 should be a parabola. And we're translated up 1. So that's like that. The other one is 4 minus x squared, so it's translated up 4 and inverted. So we get something like so. There are our two. And then the question asks between -1 and 1. So what we're looking at then is this area in here. Alright, so when we look at that, we say, alright, here's our limits. So between -1 and 1. And it's the upper one, which is the green one, which is x4 minus x squared, I should say. That one's 4 minus x squared. And the upper one is the x squared plus 1. Sorry, the lower one. So the upper one in the region we're talking about is the green one, and the lower one's the red one. If we were looking somewhere out over here, for example, that would swap, and we'll get to that. So -1 to 1 of the green one, so 4 minus x squared dx minus -1 to 1 of x squared plus 1 dx. And as I said, up here you can put those two integrals together. And so if you do that, you've got 4 taking another 1, taking 1, so it's 3. And you've got minus x squared minus another x squared, so minus 2x squared dx. Or you could do them separate, doesn't really matter. In the end, to get the answer, whether you combine it there like that or you do 2 separate integrals and then subtract those answers that you get. Alright, so the antiderivative of 3 is 3x. The antiderivative of -2x squared is alright, so you can write it like that. Alright, now we can substitute our numbers. Substitute 1 in, you get 3 there, minus 2/3. Substitute -1 in, you get -3 there, minus x -1 cubed is negative, so there we've got plus.
Wait. Okay, don't worry.
-1
Yeah.
cubed is -1 times the 2/3 that's there, -2/3, and we're subtracting that. However you want to look at that. Then you can work out those numbers, or you can. Alright, so 3 minus 2/3 would be how many thirds? 7. Minus -3 plus 2/3 is
-7.
And so we've got 14 thirds square units. All right. Now, just to go over, say something about this particular one that sometimes someone asks me about, and sometimes you might see in work solutions, because this is symmetrical about the y-axis, sometimes you might see two lots of the integral from 0 to 1. So 0 to 1 is that side, and because it's symmetrical, that side and that side are the same. So sometimes you could see it written as two lots of 0 to 1. Something that of all right, so multiple choice questions, you know, which one of the following could be used? Here's another. All right, because it's symmetrical. If it's not symmetrical, then you can't, you know, use that. But in this case,
About the x-axis.
yeah, about the y-axis.
Oh, y-axis,
Could also be yeah, because it's symmetrical about the y-axis, you could do that. So, as I said, multiple choice questions, which one of the following could represent the area? You know, there's been plenty of examples of those kind of questions on exam 2. All right. Now, this next example, the wording of this, so e.g. All right, so when you first read this one, you notice unlike the previous one, we weren't given any lines of x equals. So we kind of need to think about what could this actually mean. So if we do a sketch, again, doesn't matter how rough it is. So y equals x squared, well, it's a parabola that goes like that. And y equals 2x, well, that's a straight line that goes something like that. So when you look at this, you'll notice that they intersect. So they intersect here and they intersect here. So when it talks about the area bounded by the parabola y equals x squared and the line y equals 2x, well, here's a little area that's in between those. So we're talking about this area here in here. So to work out visually here what area we're talking about, a rough sketch tells us that. But what we do know need to know for the integral is we need to know what these points are. All right, so when we set up our integral, because we need x equals whatever to x equals whatever. Now one of those, so we need points of intersection. Alright, so that's when x squared is equal to 2x. So x squared minus 2x is equal to 0. So x is equal to 0 or x is equal to 2 is what we need. Because now we're going to, for the area, it's the upper one, which is 0 to 2 of, and here the upper one is the green one, which is 2x, minus the lower one, which is the x squared. Alright, put them together, 0 to 2, 2x minus x squared dx. So hopefully you can tell me that that's just x squared when we end to differentiate 2x, and hopefully this one then is minus x cubed on 3 between 0 and 2. Substitute in 2 squared minus 2 cubed on 3 minus 0 squared minus 0 cubed on 3. So that's just 4 minus 8 thirds. Minus 0, of course, if you want to be putting that in. So 4 minus 8 thirds is how many thirds? 4 thirds. Yep. 4 has 12 of them. 12 minus 8 is 4 square units. Alright, anything so far? No? Good. Alright. Now, sometimes, as I kind of already kind of mentioned, that if we were looking at an area that extended past there, then the function that's on top actually changes. So once we go past 2 there, instead of the green one being on top, up here the red one's on top. So when we have that case, we need to split into bits. So let's have a look at an example where we need to split into bits. Alright, so find the area of the shaded region. All right, so with this one, the shaded region is the region in between the two bits. So the key point is here. Because from 0 up to whatever value that is, the red one's on top, but then from there to pi on 2, the green one's on top. So we've got to split it up into two integrals, work out this one, work out that one, put them together. So we need to know intersection point. So, the intersection point is when sine 2x equals cos x. Bring the cos across, so sine 2x minus cos x equals 0. Sine 2x is to sine x cos x, is that correct? And I've done that because cos x is a common factor. Alright. So either cos x is equal to 0 or 2 sine x minus 1 is equal to 0. Sine x is a half. That's pi on 6 and cos x is 0 at pi on 2. Alright, now you need to do it like I've done here. Take the cos x and bring it across. Because if you just expanded like that and then cancelled the causes, one of your solution then disappears. This solution would disappear by doing that, so you always need to bring things, make it equal to 0 first before you then start doing other stuff. Otherwise, one of the solutions would go. Now in this case, we probably knew that pi on 2 was an intersection point anyway, but not always going to work out like that. So you need to make sure you do what I've done there. All right, so remember that the area that we're looking at, we do the upper minus the lower, and because it swaps, we need to change it. So our area, well, first of all, we're going 0 to pi on 6. And the upper one is the cos. Minus the lower one, which is sine 2. Dx. And then we need to add that other bit. And that other bit starts at pi on 6 and goes to pi on 2. And that other bit is sine is on top. So it's sine 2x. Minus cos dx. All right. Cos comes from sine. Negative sine 2x comes from cos 2x. What else do I need? Negative, there's already one there, so when we get another in, it's going to be a plus. And what else do I need?
2 in front.
2 in front, yeah. Avoided the mistake I made earlier today, Toby. Alright, and so then it's the same stuff that you're doing. Alright. So sine pi on 6 plus 2 cos 2 pi on 6, take sine 0 plus 2 cos 0. And from that we've got to take away 2 cos 0 minus sine 0. Now I've put the wrong things there, haven't I? That's not right. These ones here, aren't they?
Yeah.
Lucky I saw that. Alright, so it's 2 cos 2 pi on 2 minus sine pi on 2, subtract sine pi on 6 plus 2 cos 2 pi on 6. Alright, if I've got that right. Yes? No?
Why have you got a negative?
Where?
Oh, wait, no.
Hang on, I've made a mistake somewhere. Yeah, I've made a mistake here. I'm going to use the right one there. I'll just put that there. It's this, isn't it? So it's 2 cos. No,
What lies on fine grade?
Hmm?
Somewhere.
Anything else? Oh, made an error transcribing or anything? So this first bracket should be that with pi on 6 and then with 0. Yep. And this second one here should be that with pi on 2
Wait,
and pi on 6.
why have you got a plus in the first part and then a
Where?
minus? Second line down, where you've got sin x plus 2 cos.
Yep. Alright,
The plus in between them?
here.
Nope, the next one. Yep, and then you've got a minus there.
Thank you.
Thanks.
Because I made an error, that's why. Try to rush through it too quickly, that's my problem. Alright, anything else?
No, I
No?
don't think so.
Alright. Alright, so sine of pi on 6 is half. What's that? 2 pi on 6 is pi on 3. The cos of that's a half. Times 2 is 1. I think. Then, minus. Sine of 0 is 0. Cos of 0 is 1, 2 lots of that. Alright, then in the next one. 2 pi on 2, so that's pi, isn't it? Cos of pi is
Yeah.
negative 1, times 2 is negative 2. Pi on 2, sine of pi on 2 is 1, so it's another, take another 1. 2 pi on 6, so pi on 3, the cos of pi on 3 is a half, times 2 is 1. And the sine of pi on 6 is a half. Alrighty, then what do we got? 3 over 2 minus 2 negative 3 minus a half. Minus a half. I made a mistake somewhere here because I shouldn't get a negative value. Where's my mistake? Bet you I know where it is. It should be a half, shouldn't it?
Oh,
Because when you differentiate, cos becomes negative sine, you bring the thing out, so it should be a half. Oh. I did make the mistake. I thought I'd not made the error I made before, but I have. So that means that's a quarter. And that's also cos of, it's a half times another quarter. And then cos of pi, oh, wrong one. Cos of 0 is 1, so that's a half there. Yeah, it's a quarter. It's a half. Alright, quarter plus 1 is 5 quarters minus a half. Hang on, let me check that again. That's wrong, sorry, I've got that in the wrong spot. That is a half. It's that one. On 3, that's the quarter. So it's 3 quarters. I probably made the same mistake over here, have I? That's 0. I know, pi negative half. No, that one's right. Because pi on 6, pi on 3, that's the quarter there. Right, so 3 quarters minus a half plus got that right. Sine of pi on 2 is 1. Yep. Because of pi. Yep, that's all right. So, minus 3 quarters. Quarter minus a half is minus a half. No, I've made a mistake somewhere.
Oh.
It's not right. Having a bad day.
Is it in your notes or?
Yeah, it is. I can't read them from all the way over there.
So
That's
you
the
made a
problem.
mistake in your notes or?
No, I've made a mistake up here. Needs, what's this need in front of it?
A negative.
It does, doesn't it? So there's my mistake. Negative there, negative there, plus there. Negative there. Minus a half. Plus 3/4. That's better. Oh, terrible.
Is there any more examples?
No.
Okay. Where'd you put the negatives?
All right, so I forgot a negative here.
Yep.
All right, so that means there's a negative in front of this one, negative in front of that one, which then means this is plus a half, not minus a half. That's minus a quarter, not plus a quarter. And then that's correct after that. Yes, cos. Tricky when you anti-differentiate, got to remember that negative. And you've got to remember also the 1 over the dilation factor. Because there's none there. So when we go back, remember, when you go back, cos becomes negative a sine when we differentiate. So when we come this way, we're going to put the negative in there and 1 over the a. Sorry about all of that. I should know how to do that by now, after all these years, shouldn't I? Probably, yeah. All right. So other than all of those errors that I shouldn't make, any questions about the process? You're fine with the process?
Yeah.
Okay.
Ink. I know.
Question? No?
No.
All right. Set 9 then.